Greetings, everyone. Good morning, good afternoon, good evening, late into the evening for some of you. We'll give folks another minute to join in, and then we'll go ahead and get started. We have an excellent webinar for you today, so sit tight, and we'll get started in just a minute or so. But want to thank you all for being with us. It's an exciting time here at IWCS. We have our program coming together really nicely for the 75th celebration of IWCS in Orlando in early November. We hope you're keeping an eye on the program and making plans to attend. It's coming together. Registration is going to open up, I believe, early next week. So you'll be seeing a lot of information about that here coming up shortly. As the summer is dwindling away, amazing how fast the summer has come and gone. Okay, well, why don't we go ahead and get started? Again, welcome and thank you for being with us. It's a very global audience today, and for a very good topic to hear today. So again, for those of you who are with us late into the evening, we hope you have a glass of wine or a beer. And again, thank you for being with us. My name is Dave Cadu. I'm honored to be the CEO and director of IWCS, and I'll be your moderator today for this webinar. A few housekeeping items. Please note, as an attendee, you're part of a wider audience. So during the presentation, all participants will remain in listen-only mode. But also this event is being recorded, so you'll be able to watch it again. You can get to it from our website or on our YouTube channel. Typically, it will be posted within a few days. And you can also share it, obviously, with your colleagues. We encourage you to submit written questions. You can do that in the chat. If you open up the chat and on the right of your screen, type in your questions in the space at the bottom and hit the send button, and your questions will be addressed, time permitting, at the end of the presentation. So again, this webinar series event today is hosted by IWCS, our Cable and Connectivity Industry Forum. We offer a series of webinars on important trends and technologies from the perspective of our supply chain technology leaders and sponsors of IWCS. Today, we welcome Anthony Tassone of UL Solutions. He is a principal engineer out of New York in the USA. Anthony will be presenting his paper on non-fluorine and non-PFAS wire and cable compounds. Anthony Tassone, again, is a principal engineer with UL Solutions in the Engineered Materials Operating Unit. His areas of focus include telecommunication cable categories, as well as seasonal lighting for the North American market. Anthony has more than 41 years of safety certification and performance testing experience at UL Solutions across a variety of categories and functions, including engineering, operations, and conformity assessment. He is the primary member of the National Electrical Code Making Panel 3, an alternate member of NEC Code Panel 16 on limited energy, and a member of the IEC TC20 Working Group 18 and ANSI TIA 42. It's a wide variety of important organizations. He has a bachelor's degree in electrical engineering from Polytechnic University and is a New York State professional engineer. Again, Anthony, thank you for being with us today, and take it away.
Well, thank you, David. I appreciate the kind invitation to join this IWCS webinar. It was a pleasure presenting at the last IWCS, and must have been something good that you invited me back. So I appreciate being here. I also appreciate the audience for taking the time out of a very busy schedule, especially in the late evening, to join this webinar. As, and there's going to be time at the end for some questions. Dave read my bio, and that's from last year. So I had switched in the National Electrical Code. I'm now principal on panel 16 and alternate on panel 3, and we're heavily into the code panel discussions right now. So let's begin. So this is on non-fluorine and non-PFAS wire and cable compounds. UL has a program for non-PFAS for plastics. This is for wire and cable. Quick look at the agenda. We're going to go through the UL Solutions for those who may not be familiar with what UL Solutions does. An introduction to PFAS, the regulations, and what our testing protocol is for PFAS. Some things have changed since last October, and well, like anything else, technology changes and regulations change as we sit here. So a little bit about UL. A lot of people are familiar with our certification business that we do, certification, inspection, and testing. That's our TIC business, but we also partner with more than 80,000 companies on our software. We've done work with Compliance Wire and with the FDA, and we have one of the things I'm very proud of, and I look for every single day I go shopping, especially this time of year, is the billions of marks that UL appears on products. And as Dave mentioned, I sit on different code panels, but also I'm on multiple UL standards technical committees. And it's very, very enjoyable to see how requirements get developed over time. An introduction to PFAS. So what is PFAS? And if you can say this real quick, that's really impressive, was perfluoroalkyl and polyfluoroalkyl substances that contain at least one fully fluoridated carbon atom. The very complex group of manufactured chemicals that number more than 10,000. And it's difficult to test for all 10,000, but we do have testing protocol to test for known PFAS. And they can be grouped as PFAAs, polyFAs, or just PFAA precursors or other PFAS. And it has this very important carbon fluorine element. So the first time I was introduced to PFAS, we have a flame lab in our Northbrook office, and I was talking to the engineer responsible for fire extinguishers, and he was going through a change in requirements because, previous fire extinguishing foam consisted primarily of PFAS, and that has been no longer permitted in use, and they changed those chemicals in the firefighting foams because, if you firefighters at an event putting out a fire, that is then collected in the waterways. So that was my experience with PFAS. I didn't realize, I've been doing some research since I'm responsible for the category at UL, outside wire and cable, where else is this PFAS used? And what alerted me was kind of like the packaging you used to buy from some of the fast food restaurants had PFAS in it. Other polymer materials. Everybody's familiar with the cooking appliances and cooking type of things, and cookware in general that could have PFAS in it. Pesticides. The bottoms of some of the skis, right? If you go skiing, you need to have a slick surface. So some of that was using PFAS. Some of the water-resistant ski equipment, such as Gore-Tex type of jackets and things like that, originally contained PFAS. Wire and cable, I'm considering it very special because I'm involved in it, and it's kind of like what we do. But also, there are PFASs used in some of the compounds in order to comply with life safety requirements. So, and it could be embedded in the insulation jacket and other fillers of the cable. But it's also important that they're there to protect against large-scale fire events. So it's a kind of a balance. So this picture represents what I was talking about with the firefighting foam. So if a firefighter uses an extinguisher, shoots it at the fire source, that doesn't go away. It will then travel down into the local waterways. It'll get absorbed by the plants and then the animals eat the plants and the fish is in the water. So it's a really bad situation when the PFAS gets released into the environment. So general properties include environmental persistence, mobility and ability to be transported over long distances. And some PFAS chemicals are bioaccumulative, that they don't go away, they just accumulate. Other endpoints include reprotoxicity and other toxicities that I won't try to dare to say. And the properties render most conventional site cleanup and drinking water treatments ineffective. And co-exposure is common because PFAS is found in both consumer products and the environment. If you look at some of the fast food establishments that had packaging that had PFAS and you throw it in the garbage, that garbage is then collected, put into a landfill. That landfill now could have PFAS in the ground. So why are they banned? They've been around for a long time. Why are they now banned? But PFAS are persistent, toxic, and bioaccumulative. They're a forever chemical, as some people call it. Distinguishing markers include that they're persistent, they're not water soluble, and they could be deadly. So those are three things that kind of could be scary. There's an impact on human health, and the specific impacts known that's associated with PFAS include kidney and liver damage and decrease to immune systems and other negative effects on human health. So regulations, it's interesting. I presented this set of slides at IWCS last fall. And the one thing that's constant is the constant change in regulations. So at the federal level, the EPA, the U.S. Environmental Protection Agency, is taking action. And one of the things that they wrote was an act called the Toxic Substances Control Act. And recently, this was open for comment, actually April 2026, and the comments are expected to be completed or received by October 2026. So when I presented this in the fall, this was not open for comment, but now it is. So people do have ability to comment on the EPA Control Act, the Toxic Substances Control Act. And basically, it's a notification to the EPA prior to the manufacturing process that, hey, we're importing PFAS. Manufacturers and importers will be subjected to retroactive reporting as far back as 2011. And some data reported to include chemical identity, the category of use, the physical form, the volume, among other things. And there are at least close to 1,400 PFAS chemicals that are in the scope of this act. There's also a CERCLA, which is the Comprehensive Environmental Response Compensation and Liability Act. It establishes liability for facilities that use what's release and dispose of hazardous waste. This is a very good act, I think. There's a proposal to designate perfluoroalkyl acid and other PFAS as hazardous. And the advanced rulemaking established in April 2023, which could be subject to change because, like I said, the regulations keep changing, includes 7 additional PFAS and requested information on other categories of PFAS. And then there's the Resource Conservation and Recovery Act, And this proposal to add 9 specific PFAS, their salt structural isomers, to a list of hazardous constituents. And it establishes that these PFAS would have to be considered with any other corrective action taken on a facility. So these are serious federal requirements. Each state can be somewhat different. Since the beginning of 2026, just 2026, there's over 400 bills that were introduced on the state level, just on PFAS. So it's keeping the local government very busy, but there's a lot of activity and a lot of people looking at PFAS, especially on the state level. And Canada has been known to ban certain products from entering into their border, and there is a growing PFAS regulatory activity. And this was a chart that was showing the states that had prohibitions, restrictions, just the reporting requirements and notifications, a call for evaluation, and appropriations. So now the European, because European seems to, in a lot of different areas where there's restrictions on chemicals, seems to be leading this initiative. But the federal government, state, and Europe are pretty much on the same level. And when I presented this slide, SEAC, which is a Socioeconomic Analysis Committee, which is part of the European Chemical Agency, ECHA, says ECHA, and there's SEAC. Originally, we're looking at 2024 to 2025, but they received a lot of comments. And March to May of 2026, there was a 60-day public consultation, an open public consultation, specifically for the SEAC side of it. And more than 3,200 organizations, 250 individuals, and 44 countries responded with 3,511 comments. And SEAC right now is reviewing these comments, and the final opinion is not expected until the end of 2026. Overall, the comments supported a risk reduction and concerned that broad restrictions without exception would have a great economic and strategic impact. In the wire and cable world that we live in, banning PFAS in certain applications could have a great impact on economic and strategic efforts and use, and as well as if it's used to provide safety in an event of a large-scale fire event. So 2027, sorry, is it expected that the European Commission will draft final legislation? But as you can see on my slide, that was looking at prior to 2027, and this was only in October of last year. So things are moving along. And there's other regions, like I mentioned Canada, but there was an agreement at the Stockholm Convention about the limitations on PFAS. And many of the countries were falling in line with the agreement that was made at the Stockholm Convention, but there's no regulations in place. I mean, Australia had introduced some restrictions on PFAS, PFOA, and other PFAS materials. It's going to include bans and restrictions and risk management. Japan is following the Stockholm Convention, and they're concerned about the water quality. New Zealand and Colombia also have different requirements in place to address the use of PFAS in their countries. So one thing that's consistent globally in the U.S., federally in the U.S., sorry, U.S. is not a global thing yet, but globally and in the federal requirements is that the limits have pretty much stayed the same. And the conditions of restriction in the U.S. is that the total fluorine has to be less than 50 milligrams per kilogram. And in the European Union, the European Commission, the requirement is 25 parts per billion for any PFAS as measured with targeted PFAS analysis. and 250 parts per billion for the sum of PFAS, measured as the sum of targeted PFAS uh, with optionally with prior degradation, as it says on the screen. And the other thing is 50 parts per million for PFAS. And if the total fluorine exceeds 50 milligrams per kilogram, the manufacturer, importer, or downstream user shall, upon request, provide the enforcement authorities proof of the fluorine measured. And you all can help with that. It's one of the things that we do. In Asia Pacific, again, it's aligning with the Stockholm Convention. And in major APAC countries such as China, Japan, and South Korea, there appears to be general trend towards adopting and enforcing these restrictions. Again, one of the questions that come up, if regulations keep changing, why are you enforcing things? Why are you coming up with requirements? But there seems to be, based on all the requirements, a consistency among all the constituents and all the countries that are involved in this restriction. So you all felt confident that these limits will be upheld and not changed. The regulations about reporting them and changing them and testing may change, but the regulations and the restrictions will not. So where PFAS in cable compounds? So one is that they're in the actual insulation jacket and other polymers that are used in wire and cable. Um, they're in the lubricants during the extrusion process, any lubricants that's needed to help with the extrusion process. Some of the flame retardants contain some PFAS. And one of the things I learned through all this was that, one of the requirements in some of the flame tests is that the flame can drip and ignite combustible surfaces. And some of those drip inhibitors have used PFAS in the past. And again, every statement that we're making, you all developed these requirements to help support industry. These are not mandatory requirements by UL. We're not changing the safety standards as far as you have to get rid of PFAS or restrict it. This is a program we put into place to help users and manufacturers that have concern with PFAS and fluorine. So the UL Solutions PFAS testing protocols was developed by a chemical lab first, and there's a program on the QMFC2 that has these requirements. And as mentioned before, there's a total fluorine content requirement, and there's also a PFAS select PFAS target analysis. For total fluorine, we use combustion ion chromatography, and for PFAS, there's multiple methods that are used. Chromatographic test methods, including liquid chromatography, gas chromatography, and mass spectrometry. Again, there's 10,000 identified PFAS, but these are targeted PFAS that we can test to. And the ones that we can test to, the PFAS that we can test to, is outlined in UL 746G. It's an outline of investigation for non-fluorine and non-PFAS containing materials. Those of you familiar with chemicals and UL plastics programs is familiar with 746 because there's 746 A, B, C, D. For most of the plastic requirements or polymeric materials are evaluated to some standard under 746 umbrella. So G was created for the non-PFAS and non-fluorine. And it provides guidance on methods of analysis of fluorine and select PFAS. It outlines what the select PFAS substances are, defines criteria, which is consistent with the criteria previously mentioned for both non-fluorine and non-PFAS ratings, and it includes virgin and recycled materials for analysis over non-PFAS and non-fluorine materials. So the requirement in 746G is that it has to be less than 50 parts per million of fluorine when tested using combustion ion chromatography. And for non-PFAS, it has to be less than 50 parts per million of fluorine and less than 25 parts per billion of specific PFAS content. And that's described in Table 8.2 of 746G. And it has to be less than 250 parts per billion of total specific PFAS content. So non-PFAS with the total fluorine greater than 50 milligrams per kilogram, not due to polymeric PFAS. So if you have less than 25 parts per billion of specific PFAS content, which is listed in Table 8.2, and less than 250 parts per billion, but has more than 50 parts per million fluorine, not due to polymeric PFAS, this is complicated chemical analysis, then if it's not due to PFAS, then we can verify that the fluorine in the materials is not due to PFAS. So, so QMFZ2 is a plastics category that contains multiple different requirements for plastics under all the 746 type of standards. Wire and cable, again, I may be biased because I'm in wire and cable. Wire and cable could be considered different, right? Because you may need different materials in the compound to address the processes used specifically for wire and cable and also for the test requirements for different cables. But PFAS is PFAS and fluorine is fluorine. So as far as the program, we created a new CCN, a new category, we call them CCNs, called QMSD2. And it's for non-fluorine and non-PFAS containing materials for use in wire and cable. And it has the same limitations that 746G has stated. So the maximum acceptable total fluorine shall be 50 parts per million. And UL Solutions makes no representations or warranties regarding usability, public health, medical, or toxicological effects, or environmental impact of any of these. We test it using ion chromatography, and we report the results. If the material meets the requirements, that material can be covered under QMSD2. If it's used in plastics for use appliances and things like that, it could be covered on the QMFC2. Again, this is an optional program for those manufacturers of compounds for use in wire and cable. And a non-PFAS material would have to meet the table that is shown below, as we mentioned before. Less than 50 parts per million, less than 250 parts per billion, and less than 25 parts per billion individual non-polymeric PFAS. And that, again, is in the list. So in October of last year, we did not have any companies certified on the QMFC2. We do have a company. There are certifications listed on UL Product IQ. So if you go into Product IQ and search QMSD2, you will find the certifications covered on the non-fluorine and non-PFAS materials used in wire and cable. And it's basically, we'll just say it would be non-PFAS or non-fluorine as opposed to fluorine-free. So if manufacturer of cables is using a compound on the QMSD2, one, the cable has to comply with all the applicable requirements for that cable type. So if it's a communication cable, it has to comply with 444. If it's a power limited cable, it has to comply with UL 13, etc. That's the first thing, right? So the cable has to comply with the requirements. There's no changing in requirements. It still needs to meet whatever requirements are appropriate for that cable installation. But if the cable uses non-PFAS compounds in their insulation jacket, any other combustible material used in the cable, right, they will be permitted to be marked as optionally. You don't have to do this. It's an optional mark. It could be marked as non-PFAS. And cables using recognized component non-fluorinated compounds may be permitted to be surface printed as non-fluorine in the print legend. For an example, if you're in Product IQ, looking at QMSD2, you could look at DUZX, and guide information is information concerning the category. And in that, it'll give you marking requirements, optional markings, etc. But we added to the guide information with DUZX a cable where it's determined that all the combustible materials used in the construction, like I said, insulation, fillers, jackets, meet the non-fluorine and non-PFAS requirements in accordance with 746G, may be surface printed as non-fluorine, non-PFAS, or both if they comply with both. Again, this is an optional program. It's an optional mark. After the last IWCS received some criticism as why are we demanding this, and UL is not demanding it. We are trying to help our customers deal with all the regulations throughout the world that are concerned with the total fluorine and the PFAS in cables. So that's why this was developed. So the benefits of certification is it provides an easy means for specified cable manufacturers and purchasers to find compounds and cables that meet the non-PFAS requirements. If the requirement in the European Union is that you have to report the PFAS content, you can show that this particular cable or this compound does not have any PFAS because it's certified by UL Solutions. The inclusion of non-PFAS and non-fluorine compounds in the UL certification program includes testing on the follow-up. So not only do we test it originally when it's submitted by the compound manufacturer, but we will do follow-up testing on a regular basis. And that regular basis is typically an annual identification test to verify that the material hasn't changed. And the materials such as QMSD2 and the cables such as DUZX for communication cables, meeting the requirements will be published on UL Solutions online certification directory. So if a communication cable meets these requirements, they could have an optional rating shown on Product IQ that is non-fluorine or non-PFAS. And certification really creates a level playing field for the industry. It's not like I don't have any, you have some, I don't have some, you have some. It's just a documented process, and it shows who has certification of materials that do not have total fluorine over the limits or PFAS over the limits. And certification of compounds eliminates the repetitive testing and self-declaration. And it really does assist those customers, those cable manufacturers that are subject to these regulations, so that they don't have to repeat this test on every single product that they try to sell into different areas of the world. As mentioned, just since the last time we presented on this topic, the regulations surrounding PFAS at the state, federal, and global levels continue to evolve. I mean, look how many, over 400 bills since beginning of 2026, and 3,500 comments on the European Union side. So they're going to continue to evolve. That may be slowing down as things happen over time, but UL Solutions is remaining vigilant in monitoring these requirements and keeping the standards and certifications up to date. 746G is a published document that the industry can use to have the materials tested and certified. And the UL certification program provides an easy means for specifiers and other purchases to find compounds and cables that meet the non-PFAS simply by going to our UL certification website, the Product IQ, and you can find it very quickly. And it's all part of UL Solutions follow-up services program. It's not a one and done. It's something that we continue to visit the manufacturers that make these compounds and continue to test them on a regular basis. I think I'm going to pass this off to Dave to see if there was any questions.
Anthony, thank you so much for that. It is certainly a complex subject, but one that we're all trying to deal with and do the right things. One of the confusions, and it even comes across in terms of identifying the hazardous chemicals that contain fluorine and what we're trying to address with PFAS. But it's my understanding that the fluoropolymers themselves, not the chemicals of fluorine, but the fluoropolymers are not bioaccumulative, and they are in applications such as wire and cable, they're very vital in terms of performance, whether it be chemical resistance or heat or flame retardancy, smoke suppression, all those kinds of things. So in your program at UL, how do you differentiate the hazardous PFAS chemicals? How do you distinguish that versus what can be considered as the non-hazardous fluoropolymers, for example?
Yeah, with respect to communication cables, fluorine is used a lot, right? So um, that's one of the things I think they're looking at with the regulations is what comes first, right? The safety in a plenum space where you need to use fluoropolymers and not. There's a list of elements, as I mentioned in 746G, that talks about the PFAS. Um, and as far as total fluorine, uh, those are just limits. We tested it 50 parts per million, and if it meets it, then you can state that your cable is, like we have for halogen free, right? Halogen free had certain limits, and we couldn't call this fluorine free because there's an FF rating already. There's a wire type for fixture wire, so we couldn't do the FF rating. That's why we had to go with fluorine free. If someone wants to use that, just like plenums don't have, I'm not aware of any certifications that have a halogen free plenum compound. I don't expect some compounds to have a fluorine free compound because, you know, I don't think the regulations are looking at, but I'm not at a level to say one way or the other.
Yeah. And you talk about all the different regulations that are being applied in different states, different local requirements all over the world, not just in the
Yeah,
USA. But fluorine technologies are used in so many aspects of our lives, in everything from computer devices and automotive and aerospace and so many things that really do require it. So it is important to differentiate what's truly hazardous. I mean,
right.
as you mentioned, there are chemicals that need to be managed and removed from the waste streams. But the concern that I'm reading and hearing is about just anything fluorine is hazardous. And is there any way that UL is managing that commentary or that narrative in any way as you do this testing?
Well, we do the testing in accordance with this published set of requirements, right? So we know by test and we state the facts, and that's what we do. Um, but the feedback from different industry events that I attend and others attend show that they're looking for certain exceptions, right? Because the firefighting foam made sense, right? Because you firefighting foam, you spray it, it goes into the ground, it shouldn't happen. If you put it in a cable and it's put somewhere else, or if it's critical in your aircraft flying or your car doing what it needs to do, then that there should be some exceptions. I think that's what a lot of the comments have been around, and that's what we hear on the ground is that people are looking for, hey, this is a critical application, and there should be certain applications that are exempt from some of these rules. Because sometimes you have a rule, it's a blanket statement, right? Oh, everything's forbidden. Um, but, you know, and to be honest, I mean, if you look at our product IQ, I presented this last October, and we have very limited number of people that have submitted for the cable side of it. We have some on the QMFC2 side. So people are waiting in the wings to say, hey, do I need to do this? But we want to say, hey, if the regulations are this and you want us to test it, these are the requirements. We could test for it. We'll document those requirements. We're not saying we have to. We're not saying one way we agree or disagree with any of the regulations that are set forth. We're just saying if you want us to test this, we have a known level that we could test to, and we complete the testing and then just report what those results are.
Yeah. I think like a lot of ingredients in compounds and the like, um, exceptions are becoming the rules.
Yeah.
And with all the regulatory activity going on, clearly exceptions have to be written for mission critical, products and applications. And quite honestly, plenum cables and communications cables are part of that. So
Mhm.
anyway, great information, obviously, and we just have to manage it, just like other ingredients that questions have been raised, whether it be, halogenated flame retardants, whether it be any other compound ingredients. We just have to responsibly manage the bad and also, validate and talk about the good that comes along with these technologies. And with that, one of the questions that has come up here is, how will this affect FEP products? And I think you've already mentioned one primary application, but FEP in particular, and other fluoropolymers.
Well, if they can't meet the total fluorine requirements, so there got to be an exception given somewhere, right? So UL is not saying in 444 that you no longer can use FEP, right? That's a requirement. They want to use it and comply with the large scale fire test. Um, I'm- I don't want to give my personal opinion on anything because it may not be correct and it's based on what I hear and see. But again, the regulations are to address the known hazards with some of these chemicals, and they also have to take into consideration what those chemicals are used for. I remember when at one time lead was very well used in cable, right? It was, uh, and that's been taken out, right? There's regulations over a period of time where they've come up with other methods uh, and other materials to use. It seems like there's critical applications that if it's shown that they need to have certain chemicals and those chemicals are not going into the environment, or being uh, touched and used by consumers or whatever, then it looks like those exceptions may go through. I know there's a lot of discussion going on. I'm not privy to that discussion. It's just what you hear when you go to different events and what you hear from customers.
Yeah, I think that's the important
Yeah.
distinction is to take a look at the risk
Yeah.
analysis and the exposure potential, both in manufacturing but also in the consumer use, and that's where we have to keep monitoring the dialogue and make sure it's being handled. And again, we're addressing the hazards and the problems rather than materials that there aren't a problem. Um, if targeted lists and limits do change, do products need to be retested to use these certifications at UL?
If there were certifications to these requirements and those requirements changed,
Yeah,
yeah,
if the
yeah,
limits,
yeah.
if limits
If
change, do you have to come, do the certified, but do you have to recertify, I guess is the question.
if the requirements changed, right, then 746G would have to be changed, and anything that was certified in accordance with 746G would over time have to be changed. Like any other change to a standard, right? We give the manufacturers and applicants time to review the requirements and make the necessary changes. We used to call them industry fire reviews, now we call them CRCs. So at this point, we to be open is that there are no products, cable products that would be affected by this change in requirement because there's no cables that have this optional mark as to my knowledge as of yet. we're trying to promote it and see who wants it, similar to the way we promoted the halogen-free program 10 years ago. So if someone had a cable that was using a compound and that compound changed, and it would have to be reevaluated. But the cable's not tested anyway. Cable's just verifying the compound. The compound would need to be reevaluated if the limits change.
Yeah. I
It's
think
a
you've
good.
already answered this question, but I'll ask it again. Where do things stand as far as non-fluorinated plenum cables are concerned, in terms of passing the Steiner tunnel test and things like that? I think you've already touched on it.
Yeah, how manufacturers have designed cables to comply with the tests,
Yeah.
is proprietary to that cable manufacturer. But as I think it's widely known knowledge that there's materials that are used that are other than fluoropolymers in plenum cables, right? UL doesn't say you have to use an FEP. We say we have to use you have to pass the test, right? As long as you pass the test, then we document what was used in that particular construction. Nothing says you have to use one material over the other because materials change over time, and some are enhanced, some get better, some get kind of outdated. So having this doesn't say you can't use one over the other.
Yeah, I think this question gets asked all the
Yeah.
time, from a lot of different perspectives. But to your knowledge, are there any non-halogenated cable constructions that don't contain halogens in plenum cables? I don't even know
That you
if I
can.
asked the question right.
No, no, I get it.
Yeah.
If a plenum rated cable has a HF rating on it, I think there are a lot of people that desire to have that. I'm not aware of any that have achieved that. And you could search Product IQ under DUZX or any other telecom type cable, power limited, similar type of cables that have plenum ratings, and you could search for the optional dash HF. And it's public information. So I'm not aware of any, but I don't look at every single certification. But you can
Right.
find it. It's public information.
Well, with that, I want to thank the audience for the questions that you've provided, and certainly Anthony, thank you for such an excellent presentation. Very very difficult subject, and again, I think UL has done the right things to provide guidance and to provide the certifications that you do. Um, for those of you who wish to contact Anthony directly, perhaps offline with some questions or advice, you can see his contact points here on your screen. And again, I want to thank Anthony for taking the time to helping us understand the current lay of the land on this issue. I want to remind you that this webinar has been recorded and will be archived and available through our IWCS.org website and on our YouTube channel. Again, we offer these webinars each month, sometimes more than one, and our technical papers from the prior conference are used as the base, but we also offer industry trend webinars from some of our leading sponsors as well. Our next scheduled event is on Friday, September the 18th at 10:30 a.m. Eastern USA time, and each of you will be receiving a notification. And we hope that you will join us, and also feel free to share the invitation and the announcements with your colleagues so they can join as well. Before we end, I do want to recognize and thank our partner sponsors for IWCS, Again, they contribute greatly to the success of our Cable and Connectivity Industry Forum. Without their strong leadership and generosity, we would not be able to bring these important technical innovations and information to you and to our global community. So again, thank you to UL Solutions and the other leading suppliers in our industry for their kind support. I am very excited to let you know that our our conference in Orlando is coming together very rapidly, and in fact, registration should be opening early next week. We elected to wait until after the holidays that a lot of people take in the August timeframe, but be on the lookout for information for our preliminary program. Incredible content technically, as well as some intriguing special sessions that you'll be interested to be a part of. But also we'll be celebrating our 75th anniversary of IWCS. We're going to have a Cirque Royale, a circus event at the Gaylord Palms in Orlando, outside, we hope, weather permitting. But it'll be a lot of fun on the Monday evening, and everyone will be invited to participate who attend the event. So bring your family, enjoy not only the IWCS event, but also the new activities going on at Universal and Disney. A lot of good things going on. So again, our conference is taking place in early November. So please keep an eye on your email, but also visit our website to learn more as the information becomes available. But here within the next week, you'll be hearing about registration and other information. So with that, again, thank you for participating today, and wish you a fantastic weekend. And enjoy the rest of your summer. Sadly, it's coming to a close. And again, Anthony, thanks so much. Appreciate it.
Thanks, Dave. Appreciate you having me.